Imagine stepping away from your computer. Beat. And while you're gone, an AI is quietly building an entire playable 3D physics game from scratch.
That is just wild to think about.
Okay, let's unpack this. Welcome to the deep dive. We are looking at a major shift today.
Yeah, specifically Elon Musk's XAI and their launch of Grok 4.6.
They tend to launch models like SpaceX launches rockets.
Yeah.
Fast, loud, and impossible to ignore.
Oh, absolutely. But we aren't just looking at a simple version update today.
Right. We're looking at a completely different approach to artificial intelligence.
What's fascinating here is the core evolution of the model itself. Grok is fundamentally shifting its purpose. It is moving away from just being a standard chatbot, answering a quick question or writing a simple email.
It is transitioning into a system for continuous long-running work.
Exactly. From a conversational tool to a dedicated worker.
So to really understand what that means for you, we need to look under the hood. We need to know why Grok 4.6 can handle these massive tasks.
Right, because they definitely changed the training process quite a bit.
They did.
Yeah.
This is not just a minor version bump. They completely rewrote the recipe.
They absolutely did. For starters, XAI trained Grok 4.6 much longer than 4.5.
Wow.
But it is not just about the time, it is about what they actually fed it.
They pumped in massive amounts of model-generated reasoning data, right?
Yeah. They had previous AI models generate complex logical puzzles. Then they fed that synthetic logic back into Grok.
That makes the reasoning pathways much more robust.
Exactly. They also gave it highly advanced technical material and top-tier engineering data.
And they swapped out the optimizer entirely. Think of the optimizer as the core engine. It updates the AI's knowledge during training.
Changing that fundamental engine builds a much stronger foundational base.
And they did all of this before fine-tuning even started.
Right. And the most critical part of that foundation is the training style. They focused heavily on agentic reinforcement learning.
Meaning teaching AI by rewarding it for completing multi-step goals.
Spot on. They trained it by giving it increasingly complex tasks that required serious, long-term planning.
Like hardcore multi-file coding project.
Exactly. Comprehensive web development, real knowledge work, even computer-aided design files.
The goal was forcing the model to handle multi-step work seamlessly.
Okay.
It can't just answer one prompt and stop.
No, it needs to carry a thought process through 50 different steps, and it has to do that without losing its mind.
These training changes sound highly technical, but the benchmarks make the tangible difference much easier to see.
Yeah, let's look closely at those numbers. They are quite revealing for this release.
Let's start with the Artificial Analysis Intelligence Index.
Right, a very well-regarded aggregate score. Grok 4.6, high scores a 61.
That is a solid jump from Grok 4.5 score of 56.
It really is, and it matches GPT 5.6 Sol Max exactly at 61.
It sits just 1 point below Fable 5 Max at 62. So it is right there at the absolute bleeding edge.
But it gets even better from there. Look at the GDP-Val AA version 2 benchmark.
Okay.
Grok 4.6 completely dominates this specific test. It reaches a massive 1,753 ELO score.
For those unaware, an ELO score is basically like a chess ranking.
Yeah, you pit the models directly against each other in real-world scenarios.
And a 1,753 ELO beats Fable 5 Max at 1,741.
It also easily beats GPT 5.6 Sol Max, which sits at 1,728.
This specific result really matters for users. GDP-Val focuses heavily on real knowledge work.
Exactly. It doesn't just test random history trivia. It measures actual utility in messy business scenarios.
But we do have to balance that by looking at DeepSWE version 1.1.
Yeah, that benchmark is designed purely for coding.
It drops the AI into a software environment to solve complex issues. Grok 4.6 scores a 65.9% here.
That is certainly a major upgrade from the previous 54%.
But it still trails behind the true coding frontier. GPT 5.6 hits a very strong 73%.
And Fable 5 Max sitting at 70%.
So Grok 4.6 definitely has room to improve on pure software engineering.
Well, for sure.
But, I always think of benchmarks like running on a treadmill. The conditions are perfectly controlled, there are no surprises. But real software engineering is like running through a dense forest. Benchmarks miss how well an AI keeps context when things get messy. They miss the real-world feedback loops.
Yeah, absolutely.
Does obsessing over benchmark scores actually distract us from how useful a model truly is?
I really think so. Benchmarks are just static tests measuring isolated logic points. True usefulness comes from adapting dynamically over time. If an AI writes code, sees an error, and figures it out based on something from 20 minutes ago, a benchmark just doesn't capture that.
Right, real projects test context retention, not just static trivia.
Exactly. So we have to look at the ultimate software stress test.
Throwing a massive blank canvas project at the model.
Yes. We have two incredible real-world tests to look at here,
Test 1 is building a video game directly inside Grok Build.
which is their brand new integrated development environment.
The prompt asks for a first-person 3D puzzle game. Heavy inspiration from the classic game Portal.
And that means handling incredibly complex physical mechanics.
It has to figure out how to place connected portals on valid walls.
And more importantly, it has to preserve a player's exact momentum.
Right.
Imagine falling deeply into a portal on the floor. The AI must calculate that speed.
Then launch you out of a wall portal at that exact same velocity.
For an AI predicting the next word, translating that into spatial physics is mind-bending.
It also must maintain correct camera direction smoothly. It handles 3D collisions without clipping through walls.
It needs to calculate dynamic lighting and cast shadows correctly.
And write the math for all of this from scratch.
The rule for this test is incredibly strict, too. It must fix broken mechanics before adding any visual polish.
The gravity and momentum must work flawlessly before making the walls look pretty.
Yeah. Now, test 2 is a bit different.
But arguably more relevant to the average listener. It is building a complete SaaS website.
A project management app called Flowtask. This is a highly practical, everyday test.
It needs a polished landing page with a hero section.
A simple pricing tier section and a comprehensive FAQ.
It also needs a fully functional app dashboard.
We are talking a sidebar menu, project overviews, and simple analytics.
And the kicker is that it must actually work in practice.
Right. It's not just a pretty picture. It needs realistic sample data populating the dashboard.
The forms, search bars, and data filters must function properly.
If you click a filter button, the screen actually has to update.
And it has to be perfectly responsive across all devices.
Yeah, desktop, tablet, and mobile.
I have to say, I still wrestle with prompt drift myself. Beat. I'll ask an AI to write a Python script. By step 5, it forgets what database we're using and hallucinates features.
Oh, it happens to everyone. I once asked an AI to build a landing page. By the third prompt, it decided I needed a complex cryptocurrency checkout system.
Exactly. You ask for too many steps, and the AI loses the plot.
It just loses the thread entirely.
That's why Grok maintaining intense focus here is really impressive. It holds the entire project architecture in its mind.
Remembering the original goal while fixing tiny bugs along the way?
But let me ask you this. Why is simulating physics in a game a better test of an AI's brain than asking it to write an essay?
Because physics demands continuous, unbroken spatial reasoning. If an AI writes a weak sentence in an essay, you just keep reading. It still functions. But if gravity fails for a single frame in a game or a collision mesh has a tiny math error, the entire game crashes instantly. There is zero margin for error.
Exactly. Physics requires precise logic over time, not just text generation.
Yeah.
Mid-roll sponsor read, provided separately.
So we have seen how it handles standard controlled prompts.
But what happens when the wider development community gets their hands on it?
People are pushing it incredibly hard, and the results are fascinating.
How does it survive wild, unpredictable code bases?
Well, Chanyu tested Grok with a cozy 3D Unity game. The focus was strictly on the camera system.
Watching how real-time interactions flow as the player moves around.
Yeah, and that real-time flow is absolutely critical.
You notice small computational problems quickly when things move dynamically.
A static screenshot of code hides subtle structural flaws.
Right. And then Daniel Freena took it much further. He made Grok build a fast-paced snowboarding game from scratch.
That is a brilliant and punishing test. Fast movement severely stresses any physics engine.
Calculating terrain collisions in milliseconds. If physics break at high speeds, visuals won't save it.
But out of all the community tests, the bug hunt benchmark is the craziest.
Our tested Grok 4.6 on a massive scale.
A brutal benchmark featuring 105 deeply hidden bugs.
And these are spread across 2 massive real-world repositories.
Literally like finding a needle in an interconnected haystack.
You have to understand how file A affects file Z.
Exactly. And at the highest reasoning level, Grok 4.6 succeeded wildly.
Out of the 105 hidden bugs in the key, it found 27.
For context, Grok 4.5 could only find 17 on this test.
That is impressive. But this is where the story gets truly strange.
Yeah, it really does.
While searching for those 27 bugs, it found 15 completely real, hidden bugs.
Bugs the human test creators hadn't even included in the answer key.
Let's just pause on that. Beat. Plus, it fixed one specific bug that 13 other models had completely failed to solve.
Across 19 earlier runs, the AI didn't just take the tests.
It audited the test itself. It found flaws that senior developers missed.
This is a profound shift in capability. It isn't just grading against a rubric.
It's finding the flaws in the rubric itself, like a senior engineer reviewing code.
Rather than a student guessing the right answer.
But how does an AI manage to find a bug that isn't even documented in the test's answer key?
It is no longer just skimming for typos. It looks deeply at the execution flow. It traces the actual data path. It sees where the mathematical outcome contradicts the structural logic. It realizes a function will return a null value based on a database structured 3 files over. It understands the holistic system.
Yeah, it actually understands the code's intent rather than just pattern matching.
Precisely.
So we know it can build digital worlds. We know it can hunt deep bugs. The practical question for you, the listener, is clear. What is the barrier to entry here?
The pricing structure is remarkably simple. It is based on tokens.
Chunks of words or pieces of code.
Right. It costs $2 per 1 million input tokens.
The text or code you feed into it.
And it costs $6 per 1 million output tokens.
The code it generates back for you.
Output is always more expensive. Generating new logic requires vastly more computing power.
And there is a fast variant available, right?
Yes, for when you need answers instantly. That costs double the standard price.
Where can people actually use it?
It is fully integrated into Cursor right now.
A very popular AI code editor.
It is on Grok Build. You can use the XAI API directly.
It's also on OpenRouter, Vercel, and Cloudflare.
Very wide availability right out of the gate.
But let's be honest about the target demographic. Who is this actually built for?
Let's break down the specific user profiles. It is highly valuable for dedicated developers.
They need this context retention for massive code bases.
It is absolutely perfect for builders, people prototyping games, or SaaS platforms.
And it is explicitly built for agent users.
People running long, complicated, multi-step workflows that might take hours.
But it is not necessary for the casual user.
Definitively not. If you just want to brainstorm ideas or summarize an article, you do not need this.
Even the fast variant is extreme overkill for daily tasks.
Oh, yeah. Completely unnecessary.
Tools are only as good as the problems you have to solve. Using Grok 4.6 to write a grocery list is like driving a Formula One car to the supermarket.
That is a great way to put it.
Sure, it's an incredible machine, but it's built for high-speed performance on a track.
If you drive it to the grocery store, the engine literally overheats.
Because it's going too slow. And there's no trunk for your groceries anyway.
You're wasting massive compute on simple text generation.
Should a casual user trying to learn a new topic even bother opening the paid interface?
Probably not. The free tools handle basic learning and conversational brainstorming perfectly fine. You only need these high-tier tools for complex, persistent problem-solving requiring hundreds of pages of context.
Basically, stick to free tools unless you're building multi-step projects.
Exactly.
So, as we wrap this up, we need to connect these specific use cases to a much grander vision.
We have to look at where XAI is heading next.
The big idea here isn't just the Grok 4.6 model itself.
No, the real story is the ecosystem. Grok bot and Grok AI agents.
This is a massive shift in the paradigm of computing.
We are moving rapidly toward AI that holds incredibly deep context.
It can take a highly complex task and just keep working in the cloud.
It doesn't start from zero every single time you open a chat window.
Right, and it changes the workflow completely.
You hand over a massive, tedious task and you go to sleep.
Like refactoring an entire database.
The agent just keeps building, testing, failing, fixing, and iterating.
While you are completely disconnected.
Yeah.
Whoa. 2-sec silence. Imagine an agent that just keeps coding in the cloud, expanding a software universe long after you've closed your laptop.
It is exactly like having a tireless, brilliant digital colleague.
It never stops iterating.
It never loses the thread because it got distracted. It just keeps pushing the project forward.
Which is incredible.
Yeah.
But it also forces us to ask a difficult question as we look to the future. If an AI agent becomes reliable enough to do the heavy lifting of software engineering while you sleep, beat, do your role shift fundamentally?
That is the big question.
Do you transition from being a builder who writes every line to simply being an editor of grand ideas?
Wow.
And ultimately, are we truly ready to trust the foundation of our digital world to code that we didn't actually write?
That is something we all need to think about.
Thank you for taking this deep dive with us today.